Okay, you're given the equation of this parabola, which opens upward because the coefficient of x squared is positive. And you're asked to find a vertex, the axis of symmetry, the y-intercept, and the coordinates of the roots, or the zeros. There's two ways to find the vertex. One way is to find the axis of symmetry first. To find the axis of symmetry of a quadratic function that looks like this, the axis of symmetry is located at the line, the vertical line, x equals the opposite of b over 2a. So for our particular problem, x equals the opposite of b would be negative 12 over 2a would be 8, which reduces to negative 3/2. So the axis of symmetry is the line x equals negative 3/2. The vertex has to lie on that line. So to find the y-coordinate of the vertex, we can plug negative 3/2 into the function, which is what happened right here. And if you simplify that, you get negative 10. So the vertex is at negative 3/2, comma, negative 10. And we already have seen that the axis of symmetry is x equals negative 3/2. The y-intercept just means that what is the y-coordinate when x? So if you 0, those first two terms just disappear, and the y-coordinate of the vertex of the y-intercept is negative 1. Okay, now here's the other way to convert to vertex form. It's a process called completing the square. For the first two terms, you can factor out the a, which is convenient, that 12 is divisible by 4, and kind of put a parentheses here to form a trinomial. We want to turn that trinomial into a perfect square. So to complete the square, we take half of b, which is 3/2, and square it, which is 9/4. Now by putting 9/4 in here, I've really added 4 times 9/4 to the right side of the equal sign, and the 4's cancel out, so I've really added 9. So to keep it in balance, I have to subtract 9 out here. And then I can rewrite this trinomial, perfect square trinomial, as x plus 3/2, the quantity squared. And now in vertex form, it's easy to identify the vertex. Negative 3/2, comma, negative 10. So in vertex form, this has to be a minus sign. So you think of it as x minus a negative 3/2. And there's the x coordinate of the vertex. Okay, to find the zeros, we want to know when does this function equal 0. Unfortunately, it doesn't factor. We don't have rational roots, so we'll have to use the quadratic formula, or you could also solve it by completing the square, but usually we use the quadratic formula. So opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. And the number inside the radical is 160, but you can think of that as 16 times 10, and the square root of 16 is 4. And then you can see every term, numerator and denominator, is divisible by 4. So there's the simplest way to write one of the roots. The other root would be negative 3 minus the square root of 10 all over 2. And here's a picture of the graph. The green dashed line is the axis of symmetry. Here's the vertex, negative 3/2, negative 10. These are the roots with decimal approximations for them. But here are the exact values. And you can see if I write this in function notation that the y-coordinate is 0 for those roots. So those indeed are the roots. Okay, there you go. Hope that helped. If you have any questions, post a comment.